Noise pollution. Sources of noise pollution.
Transportation. Road traffic, which includes cars, trucks, and buses, is a major source. Then we have railways and, of course, aircraft.
Industrial activities. Manufacturing plants are significant contributors. Construction sites and mining operations also play a big role in noise pollution.
Urban activities contribute significantly to noise pollution. We have loudspeakers and public announcements that are often used for various purposes. Then there are events and gatherings, which can get quite noisy. And of course, household appliances and tools also add to the overall noise level in urban areas.
Natural sources of noise also play a role in our sound environment. Thunderstorms with their powerful claps of thunder can be quite startling. Wildlife sounds such as birds chirping or animals calling add to the natural soundscape we experience. Weighting networks are crucial in measuring and understanding noise levels. A-Weighting, or dBA, mimics human ear sensitivity to sound and is the most commonly used weighting network. B-Weighting, or dBB, is less common and is used for intermediate sound levels. C-Weighting, or dBC, is used for high sound levels and provides a flat response across frequencies. Measurement of noise indices. First, we have the LEC, or equivalent continuous sound level. This index represents a constant sound level over a specific period that has the same acoustic energy as the varying levels during that period. Next, there's L10. This is the sound level exceeded for 10% of the measurement period, indicating high noise levels. Then we have L90. This is the sound level exceeded for 90% of the measurement period, representing background noise levels. Following that, we have L50. This is the sound level exceeded for 50% of the measurement period, representing median noise levels. Another important index is the LDN, or day-night average sound level. This is an average sound level over 24 hours with a 10 decibel penalty added to nighttime noise from 10 p.m. to 7 a.m. to account for increased sensitivity to noise at night. Lastly, we have the TNI, or Traffic Noise Index. This index combines L10, L90 and LEC to assess the impact of traffic noise on the environment. Noise dose and noise pollution standards. Let's dive in. Noise dose refers to the cumulative exposure to noise over a period, often measured in percentage relative to permissible exposure limits. Noise pollution standards are crucial for maintaining a healthy environment. The World Health Organization, or WHO, recommends maximum noise levels for various environments, for instance, 55 decibels for residential areas during the day. In India, the Central Pollution Control Board, or CPCB, sets noise limits for different zones, including industrial, commercial, residential, and silent zones.
Noise control and abatement measures are essential to mitigate the effects of noise pollution. Active methods include active noise control, or ANC, which uses sound waves to cancel out unwanted noise. This is commonly used in headphones and some industrial applications. Passive methods are also quite effective. Barriers, such as sound barriers along highways and around industrial sites, help block noise. Insulation, using soundproofing materials in buildings, is another method. Buffers, like green belts or vegetation, can absorb and block noise as well.
Vibrations and their measurements are important aspects to consider in noise pollution studies. Sources of vibrations include machinery and equipment, transportation like trains and heavy vehicles, and construction activities. When it comes to measurement, seismometers are used to measure ground vibrations, accelerometers measure acceleration due to vibrations, and vibration meters are used to assess the intensity and frequency of vibrations.
The impact of noise and vibrations on human health is significant and multifaceted. Health effects of noise include hearing loss, where prolonged exposure to high noise levels can cause permanent hearing damage. Cardiovascular problems, such as increased risk of hypertension, heart disease, and stroke, are also notable. Sleep disturbances due to noise can disrupt sleep patterns, leading to fatigue and reduced cognitive function. Chronic noise exposure can increase stress and anxiety, contributing to mental health issues. Health effects of vibrations are equally concerning. Musculoskeletal disorders can arise from long-term exposure to vibrations, leading to joint and muscle pain. Circulatory problems like hand-arm vibration syndrome, HAVS, can affect blood circulation. Vibrations can also impact the nervous system, causing numbness and tingling in extremities. Effective noise and vibration control measures, combined with adherence to standards and guidelines, are essential to minimize their adverse impacts on human health and well-being.